This morning I told you about the afternoon in 2003 when 55 million people lost power. And I said the reason the alarms went quiet was something called a race condition. I did not explain what that is, so let me, because it is one of the few bugs that has genuinely killed people, and because it is the single hardest kind of bug to catch. Here is the whole idea. Two things are happening at the same time, and they both reach for the same thing. Imagine two people sharing one notepad. Both read the number written on it. Both add 1 in their head. Both write their answer down. The number went up by 1, not 2, because they were working from the same starting point. Nobody did anything wrong. Each of them followed the instructions perfectly. The bug lives in the gap between reading and writing, and whether you land in that gap depends entirely on timing. That timing dependence is what makes these so nasty. Most bugs are loyal. Give them the same input and they fail the same way every time, which means you can chase them. A race condition might need two things to land within a few milliseconds of each other. Run the code 1,000 times and it is fine. Run it on a faster machine or a busier one or under real load with real users, and suddenly it is not. Worse, the moment you attach a debugger, you slow everything down, the gap closes, and the bug politely disappears while you are looking straight at it. Now the part that matters. Between 1985 and 1987, a radiation therapy machine called the Therac 25 delivered massive overdoses to at least 6 patients. 3 of them died. The machine could run in 2 modes. A low-power electron beam aimed straight at the patient, and a high-power beam that was only safe because a heavy metal target swung into the path first to absorb most of it. The software chose the mode, and the software moved the target. The fault was this. If the operator started setting up one mode, then changed their mind and edited the prescription within about 8 seconds, one part of the program updated the settings while another part had already begun its own work, and the machine could fire the high-power beam with the target still out of the way. And here is the detail I cannot get past. 8 seconds is fast. To trigger it, you had to be quick and fluent at the keyboard, which means the operators most likely to cause it were the experienced ones. The better you were at your job, the more likely you were to hit it. There is a second half to that story, and it is the half engineers should take with them. The previous model, the Therac 20, had the same class of software fault. It never hurt anyone because it had physical hardware interlocks. Actual fuses and switches that made the dangerous configuration impossible, no matter what the software believed. On the 25, those interlocks were removed, and safety was handed entirely to the software. The bug did not change. What changed was that nothing was left to catch it. Which brings us back to that control room in Ohio. Different industry, different decade, same shape of failure. 2 parts of the alarm system reached for the same data at the same instant and ended up waiting on each other, and the alarm stopped. Nobody wrote a line of code that said, "Stop warning the operators." It emerged from 2 correct pieces of code meeting at the wrong microsecond. So what actually helps? The honest answer is that the fixes are mostly about giving up sharing. You can put a lock around the shared thing so only one worker touches it at a time, which works and costs you speed. You can make the data immutable so nobody can change it out from under anyone. You can give exactly one owner the right to write and make everyone else ask it. Or best of all, you can arrange things so there is nothing shared to race over in the first place. And where the stakes are physical, you keep the interlock. Do not let software be the only thing standing between a machine and a person. The reason race conditions deserve real respect is not that they are exotic. It is that every piece of the system passes review on its own. Each function is correct. Each test goes green. The failure lives in the space between 2 correct things, and that space only opens under timing you did not think to try. Follow Kompile for what's under the hood.